In fishery science, a cohort is the collection of fish that results from one annual reproduction. So all the fish born in a given year are called a cohort for that year. For Pacific halibut, n of t equals n naught e to the negative 0.2t represents the number of fish still alive after t years, where n naught represents the initial size of that cohort, so the number of fish born in that given year. Approximate the percentage of the original number still alive after 10 years. Well, we're not given any information about n naught, so it turns out that must be irrelevant if we're being asked to solve the problem anyway. The percentage alive would be equal to n of t divided by n naught. That is the number alive at the moment divided by the number that were alive at the beginning of that year when the fish were born, when that cohort was born. Of course, that won't quite be a percentage. That'll be a decimal. We can multiply by 100% to turn that into a percentage. So let's look back at our equation. We're supposed to find an expression for the percentage that will be alive after 10 years. So that would be n of 10 divided by this n naught times 100%. Let's substitute n of 10. Well, n of 10 should be n naught e to the negative 0.2 times 10. Now we're going to divide by n naught. There's why n naught was not provided. It turns out it cancels out with the n naught in n of t. Multiply by 100%. Now it's time to go grab a calculator. I'll pause it while I do that. E to the negative 0.2 times 10, or e to the negative 2, is equal to 0.135. Actually, that's rounded to the 3 decimal points, so I'll change this to approximately equal to. Then times 100%, that gives me 13.5%. So the number alive after 10 years is about 13.5%. Just for completeness, I'm curious what n of 20 is. Our work will be the same. We'll need to compute e to the negative 0.2 times 20 instead. And you can do that. I'll just grab my calculator and punch in that value and then write it in. That's a value of 0.18 times 100%. That's 0.018 or 1.8%. So thinking about this in the context of the problem, after 10 years, about 13.5% of the original cohort would still be alive. After 20 years, only about 2% of that cohort would still be alive.